that City guy like takes his wife out on like a country date, and it's so cute.
It's
literally the cutest video I've ever
Okay.
seen. It was like a really like not a city, like a really nice.
Alright, this is going to be something that's big for pretty much this whole semester. Angles in standard position. So this is going to be over here. So how does this draw it? Okay, what am I drawing? Coordinate plane. An angle in standard position is always going to start, this will always be right here. This will be the initial side. Okay, then determining which way it goes. So if it goes counterclockwise, then it's a positive angle. If it goes if it goes clockwise, then it's a negative angle. So counterclockwise, so opposite of the way a clock moves, that's a positive angle, other way is a negative angle. Not very straight line. You see the paper plates that they did last year?
Oh yeah.
Okay. So that's called a unit. This is not very good drawing. I'm not an artist.
Yeah.
Is that a little bit better?
No.
Just a little bit.
The other side.
Looks like it's just kind of long.
That top right corner is really big. Oh.
Oh.
Okay.
That looks like an egg.
That's as good as it's gonna get. Okay, so this is my X and Y. If this is where I'm starting, and I don't go up from this, what degrees would that be? 0. As I go here, what would this top degrees be?
90.
Okay, why is it 90? Okay, it makes a right angle, right? Okay, everything I'm talking about, like today, tomorrow, all next week, is like foundational. So if there's something that doesn't make sense, ask questions. Okay? So where would this be over here? What's a straight line?
180.
Okay, down here would be,
270.
okay, how do you get 270? Okay, you added another 90. So each quarter of the circle is 90 degrees. So I went 90, then I went another right angle, we're at 180, another right angle. So if I go back, how many degrees is a full circle?
360.
Okay, where would negative 90 degrees be? 270 down here, 270, right? Because you go backwards. So negative 90 and 270 are the same exact place. They would look exactly the same. Okay, does that make sense? Positive, negative. We will talk about angles that are bigger than 360, but everything will have to fit somewhere in here. So even if I said we're 720, 720 is still going to end right here. It's just 2 circles around. Okay. Does that make sense? Is there any questions about positive versus negative? I don't know what's down here, but what's over there? Oh, not for the fun stuff. Radian. Open your books to page 283. If you don't have your book with you, maybe somebody next to you has theirs. Page 283.
You want us to write all that down?
The circle is the
You can write whatever you want to write down.
Which one was it?
I mean, do you know what theta and arc and radius is? You know what all that is, then you would need to write it down. You would just need to write down the formula. Okay, there's two, like on the left-hand side of the page, there's 3 figures, right? I think so, on the book. Yeah, there's 3 things. You're gonna go look at the middle one on page 283. Okay, and it should say like 1 radian. Everybody see what I'm talking about? 2 radian. Please say yes or no.
Yeah.
Okay. Okay, here's how a radian is measured. A radian is the length of the radius along the arc of the circle. So where's the arc of the circle? The outside. Okay? So what you would do to find a radian is you take the length of this, whatever the length of it is, and that measurement goes around the curvature of the arc of the circle. So if this is 4 inches, then that means I need to measure 4 inches to find my radian. And then each time, whatever this length is, keeps getting measured around. So here, and here, and here, here. See that on that picture on the book? Okay. What it's doing, and this is the part I think is really confusing for most people. It's taking the radius and it's taking it on the arc. That same length gets measured around. And wherever you stop, you continue again. Okay? Yes? Has anybody's brain hurt yet? Everybody's okay? Alright, so if this is zero, this is where we start. Okay, that's 0 radians. There's 1 radian, 2 radian, 3. This right here is pi. Okay, what's pi equal to?
3.14.
Okay, so there's 3 radians. This is 3.14 radians. So you may know if that's pi, what's a full circle? What would this be? 2 pi. Which is, if I take 3.14 times 2, that'd be 6.28 radians. Which makes sense, if this is 3, 3.14 is going to have to be past it. There's 6.28. Any guesses on what my radian is up here? Has pi in it.
Pi over 2.
Pi over 2. How'd you get pi over 2? Whoever said it's right.
I don't know, it's just like it's like 2.5 times pi, but you're just like dividing it by 2. 'cause it's
Okay,
half
so
of pi.
it's half, right? Because if this is 0 to 1 pi, you're putting it in half, it's going to be half pi. What about down here? What's halfway between 1 pi and 2 pi? 1.5. What's that as an improper fraction? Yeah, so 3 pi over 2. Okay, take a break, like 2 to 3 minutes, because I can already see you're zoning out. Okay, stop writing, take a break, stretch, talk. Just remember whatever you do is also on video. I'm serious. Stop writing. Y'all enough time to finish writing whatever you're writing, just right now.
You're doing pretty good. Smoke a jam. Wait, what did you say?
I wouldn't use all that.
Have you ever wanted to do that thing? Like straight up. I heard that song.
Heads first.
I know. That was my fault. I know, but he said he looked and I said, yeah, you're fine. And I looked this way instead of this way, so I think it was really good. And then we were driving on the highway and he ran straight out in front of us. He had this like I'm really good.
There you go.
Is a lizard look creepy?
There you go.
Totally.
Go for it.
Okay. All right. So when you're thinking about the technical definition of radian, do you know what this symbol means?
No.
Okay.
Measure of central angle.
Okay, but what Greek letter it is?
Nope.
Okay. This is called theta. Okay. And where you're gonna see it is when you're like looking at an angle. They'll have the angle, but then they'll put it in between. It just means the measurement of the angle. Central angle is the angle that's on the inside of the, that's why it's called the central angle. Okay? The arc will always be labeled S, is when you're looking at the curvature. That's on the outside of the circle. If you're thinking of the big circle, that's an arc. And then this would be your radius, which is R. Okay, so to find your angle, find the angle that's in there when you're thinking radians. You take your length of your arc by the length of your radius. Okay, when you're doing with a unit circle, it's going to be 1. Don't stress out about unit circles yet, we're not even there. Okay, this stuff right here we'll get to. I just want you to kind of think where things go. Everybody good? Go to the next page. Okay. What's an acute angle? Okay, and they have to be positive angles. So two positive, hang on, that's not right. I'm thinking complementary. You're right. One positive angle plus an angle. Positive angle less than 90 degrees. Or when we talk about radian, 90 degrees is the same thing as pi over 2. Okay, what about an obtuse angle? Bigger than 90, but less than 180. Okay, you guys have never done angles, I don't think you have, that are bigger than a line. Have you? Okay. I don't think you have. So a positive angle, positive 2, between 90 degrees and 180 degrees, which in radians, that would be between pi over 2 and pi. Everybody good with acute and obtuse angles?
Yeah.
Okay. Okay, coterminal angles should be something that's brand new. A coterminal angle has the same initial and terminal sides, which means you're just adding a full circle to it, or if you want to do the other way, subtracting a full circle from it. So how big is the circle? 360 degrees, or if it's in radians, 2 pi. Good. So when you're thinking of coterminal angles, you would either add 360 degrees or subtract 360 degrees. And if that's in radians, you would add 2 pi or subtract 2 pi. I think this will make more sense when we actually do a problem that's like it. Just trying to make sure you know definitions right now. And then the last 2 things we'll talk about today are complementary angles and supplementary angles. Okay, complementary. First off, they have to be 2 positive angles, okay, and they equal 90 degrees. Okay, so if I was given the angle 70 degrees, what would my complementary angle be? 20 degrees. Okay, but if I'm given the angle 100 degrees, that doesn't have a complementary because you can't have a negative. Okay, so I guess negative 10 does add to equal 90, but they have to be 2 positive angles. So if it's already bigger than 90, it doesn't have a complement. Okay, same thing with supplementary. They're 2 positive angles whose sum is either pi or 180 degrees, depending on which way you're looking at it. So like if I had 150 degrees, my supplementary would be 30 degrees. But if I had like 250, that doesn't have a supplementary because it's already bigger than 180. So if it's bigger than the sum, it doesn't have a complement or supplement, depending on which one you're talking about. The only thing new on this slide, I think, was coterminal.